Okay, in the last class, I gave you problems, these problems as homework. So let us do these problems. I'll go over each of them because I like to work with these problems. So I'll just go over each one of them. Uh, so utility XY is something we did last class. Now, min of this thing, utility equals to, by the way, any doubts from last class of microeconomics, apart from these questions, obviously. If you have any doubts from these chapters, we can also discuss those. Break it up at any point of time. Min of x comma to y plus min of 2x comma y. So I want to solve this utility problem. Now, as you can see, this main function. So let me call this as u1 and this as u2. So we just have u equals to u1 plus u2. All right. Let me represent this with different colors. Plus u. Now what is u1? U1 is min of x comma to y. So u1 is, since it is min of x comma to y, so u1 will be equal to x if x is less than 2y, and it will be equal to 2y if x is greater than 2y. So the dividing line is x equal to 2y between these two functions. So I have to draw the line x equals to 2y. So this is the boundary line, so to say. So I wish to draw this boundary line. So that would be the first thing I have to do. So x equals to 2y is y equals to x by 2. So it will be a slope half line, m equals to half. All right. To the right of this line, you would have x greater. So you would have x greater than 2y. So u1 would be equal to, when x is greater than 2y, u1 is equals to 2y. And to the left of this line, you would have x less than 2y. So u1 would be equal to x. Now this function u2, this is min of 2x comma y. So this function will be equal to 2x if 2x is less than y, and it will be equal to y if 2x is greater than y. So first of all, I want to draw the function y equals to 2x. So that would be a function with slope 2. So m equals to 2. All right, to the right of this red line, all the region to the right of this line would have 2x greater than y. So utility 2 would be equal to y. Whereas to the left of this line, you would have the opposite. So u2 would be equal to 2x. Okay, so basically I have three different regions now. In region 1, u1 is x and u2 is 2x. In region 2, you have u1 equals to, since u1 is decided by the position relative to the blue line. So since you are to the left of the blue line, you would still follow this rule. So u1 is going to be equal to x, u2 is going to be equal to y now. And in the third region, you would have u1 equals to 2y and u2 equals to y. So in effect, in these three regions, I have u1 plus u2 is my final utility value. So utility value here would be x plus 2x, that is 3x. Here it would be x plus y, and here it would be 2y plus y. So that is just equal to. You didn't get notification for today's class? Well, I sent a message for today's class, didn't I? Let me just send a message again. What is invite? Right. Invite link. Send this invite link. Sorry for this thing. I don't know. Usually, I think you should get notified. Anyway, coming back. So we have 3 zones now, and in each zone, we have a different utility function. So now let us draw the overall picture. So in the overall picture, we have 2 lines. One is your y equals to x by 2. Other is your y equals to 2x. Okay. And in this region, your utility is just summation of these 2 things. So that is 3x. In here, your utility is summation of these 2 things. Okay, x and y. So that is just x plus y. And in here, your utility is summation of these 2 things. So that is 3y. Okay, so that's how things stack up. 3x, x plus y, 3y. Now let's take any utility value to end this thing. So utility is, let's say, 6. So this becomes 3y equals to 6. So y equals to 2. So y equals to 2 is basically a horizontal line. So it would look like this, a horizontal line. In here you have x plus y equals to 6. So that would be a 45-degree line like this. Right? And in here you have 3x equals to 6. So x equals to 2. So it would look like this. All right. So this is what your indifference curves would be like. Okay. So this is going to be your shape of the indifference curves. So that's question number, that was question number 2. Now question number 3, min of x square comma y. So just tell me if you have any doubts as
So
with the thing. Yeah. Who's
can
this?
you please
Kritika.
show the previous graph?
This one?
Yeah, just
Yeah. So what's happening is that I have broken down this entire utility function u in 2 parts. U1, which is the left part, U2, which is the right part. So U1 can be, now U1 is min of x comma 2y. So U1 will report a value x when x is less than 2y, and it will report a value 2y when x is greater than 2y. Right? So depending on which of these things is true, it will report these values. So according to that, I draw a line here. Right? And this just gives me the dividing line. To the right of this blue dashed line, x is greater than y, so u1 would be equal to 2y. Right? And to the left, you would have this x less than 2y, so you would have u1 equals to x. So to this entire region to the left, in the entire region to the left, you would have u1 equals to x. In the entire region to the right, you would have u1 equals to 2y. And you do the similar thing now for u2 function. So for u2 function, the dividing line becomes 2x equals to y, right? Because this is min of 2x and y. So the dividing line becomes 2x equals to y. So to the right of this red function, to the entire right of the red function, you have 2x greater than y. And so u2 will be equal to y. And to the left, you have u2 equals to 2x by similar logic. So in effect, you have three regions now, region to the left of red line, between red and blue lines, and to the right of blue lines. So accordingly, we just add the different u1, u2 functions to get the summation values. So here you have functions u1, u2, which look like this. In here you have like this, and in here you have like this. This should be u1. And then I just add these things up. This is region 1. Okay, so you have three regions and different regions. So here you have the final utility as x plus 2x. So that is 3x, x plus y, and 2y plus y. So these are going to be the utility values in the three different results. All right. Next is u is min of x square comma y. Can anybody tell me what this graph would look like? If anybody has drawn it, can anybody tell me what it would look like?
So it will be L shape and the it will pass through y is equal to root x line.
Very good. So it will pass through the y equals to x, right? So the only difference here is that uh, so you have utility equals to, so this is question 3, utility equals to min of x square comma y. Okay, so the dividend, so this function will report value as x square if x square is less than y, and it will report a value y if x square is greater than y. So based on this, the division line is going to be x square equal to y. So now I need to draw the x square equals to y line first. So y equals to x square. So y equals to x square basically looks like this, right? So this is your y equals to x square. To the right of this line, x is higher. So x square would be higher. So utility would be equal to y. And to the left of this line, utility would be equal to x square. Now, after that, take any utility value. So some utility value which is perfect square is 4. So let us take utility value equals to 4. So 4 equals to y, y equals to 4. So that becomes horizontal line. And x square equals to 4 is nothing but x equals to 2. Right? So in the first quadrant, x square equals to 2 implies that x equals to 2. So x equals to 2 is going to be this line. So it's basically going to be L-shaped curves, but the vertices, the locus of vertices now is not going to be a linear line. So the difference here with respect to our difference between this case and utility equals to min of x comma y. So min of x comma y, what it looks like is that there'll be 45-degree line here, right? And then you would have L-shaped curves like this. So this is the difference here. So the L-shaped curves remain, but the vertices are not now going to be along this y equals to x square line. Whereas in utility equals to min of x plus y, this used to be the x equals to y line. So this is the difference. Okay, max of x comma y. Can anybody tell me what the function is going to be now? Max of x comma y.
It will be inverted L shape passing
Very
through
good. It will
x
be
is equal
inverted
to y.
L-shaped curves. So in every question, the starting point is always, so what I want you to not, I don't want you to remember L shape, inverted L shape. If you remember, great. But the more important thing is how to solve it. So utility is max of x comma y, right? So utility will report a value x if x is greater than y, and it will report a value y if y is greater than x. So I just draw these. The division line is x equals to y. Okay, so the division line is when these two things are equal. So that is just x equals to y. So I draw this x equals to y line. And after that, to the right of this line, you have x greater than y, which implies that utility would be equal to x. To the left of this line, you would have x less than y, which implies utility would be equal to y. Then take any value, let's say 1. So x equals to 1. So x equals to 1 is now vertical line. This is 1. So all the points for x equals to 1 are now vertical lines. But x equals to 1 is valid only to the right of this line. To the left of this division line, the valid thing is y equals to 1. So y equals to 1 looks like this. So the curves are now going to look like this. So inverted L-shaped curves. Okay. All right. Max of min of x comma 2y comma min of 2x comma y. Can anybody tell me what this would look like? Okay, this is a slightly difficult one. Utility is max of min of x comma 2y comma min of 2x comma y. Okay, so you can again you can call this as u1, this as u2. So now your utility is max of u1 comma u2. All right, now what is u1 and u2? Let me represent them with different colors. That would be easier. So in the Cartesian plane now, I'm going to now breeze through some of the steps because the basics are now clear. So x comma 2y. So the division line is y equals to x by 2. So I can draw the y equals to x by 2 line, which is going to be slope half. Okay, so to the right, x is larger. So you would have u1 equals to x. The smaller value is going to be, no, sorry, u1 equals to 2y. And to the left, you would have u1 equals to x. All right, now for the u2, for the u2 thing, you have min of 2x and y. So y equals to 2x is going to be the dividing line. All right, to the left, you would have min of 2x and y is going to be 2x. The x variable is smaller to the left, right? So here you would have u2 equals to 2x. And here you would have u2 equals to uh, uh, y. Okay. In the intermediate region, since it is left of the black line, you would have u1 equals to x. And since it is right of the red line, you would have u2 equals to y. Okay, right of the red line is y. Left of the black line is x. So it is similar to what I had earlier. The only thing is now instead of u1 plus u2, okay, if you remember question number 2, it was u1 plus u2. Right? You have utility as u1 plus u2. So everything till this point is similar. The only thing is in the end, I'm not doing u1 plus u2. I'm doing max of u1 comma u2. Okay. Now, suppose I represent this as green. Okay. So u equals to max of u1 comma u2. What is going to be the max of x and 2x? What is going to be the max of x and 2x?
2x.
2x. Very good. So for all positive values of x, since we are only dealing with positive values of x, the max of x and 2x is going to be 2x, right? Uh, so here you have u equals to 2x. The larger value is 2x. Now, come to region 3 first. What is going to be the larger of 2y and y? The larger of 2y and y. So if you guys give me answers fast, the lecture gets over fast.
2y.
2y, yeah. So utility equals to 2y. Okay. Now let me ask somebody, let's say Anuradha. Anuradha. Okay. In the intermediate region, which of these quantities is going to be larger, Anuradha? X or Y? This line is y equals to 2x. This red line is y equals to 2x. This blue line is y equals to x by 2 or 2x equals to y. So in this intermediate region, I have identified that to the right of blue line, 2y is larger. To the left of the red line, 2x is larger. So in the intermediate region, which of these is going to be larger, x or y?
So x plus y.
No, I'm asking you, in दोनों में से बड़ा क्या होगा? Is x larger or is y larger? I'm not giving you freedom to decide a new function. I'm saying which of these things is going to be larger. How do we decide?
I don't know.
Yeah, you don't know, but how do we decide? Suppose I give you just min of x comma y. Let's say I give you this function. I ask you कि when does it report the value x? तो हम कैसे decide कर देते हैं?
So when x is smaller than y.
Okay, very good. So in this region, in general x smaller than y के लिए मैं कौन सी line draw करता हूँ? To determine the region, how would I find in which region is x larger or which region is y larger?
So by drawing the line x equal to y.
Very good. So you have to draw the line x equals to y. So the line x equals to y, what is the line slope of the line x equals to y?
45 degrees.
No, slope is not the angle. Slope is the tan of that angle. So what is the slope? Remember, y equals to mx plus c. में m जो होता है, that is the slope value. Okay. Yeah, 1. So m, because we are doing y equals to x, basically c is 0. So this is m equals to 1. So slope is 1. Here slope is 2. Here slope is half. If you resolve this line, this becomes y equals to half x. So the slope of this line is m equals to half. And the slope of the red line is m equals to 2. So the division line for deciding which of these quantities is going to be larger is m equals to 1 line, which will incidentally be between these two curves. So I will have to draw a third line now, which is your x equals to y. Okay, so this third line now will determine कि कहाँ पे ज़्यादा है. So this is x equals to y. Okay. In this entire region, u1 and u2 do not change. So u1 is still x, and u2 is still y. Okay, for this entire region, u1 is x, u2 is y. But to the left, what happens is now x is smaller. So I'm looking for max of x and y. So since to the left x is smaller, utility value, which is the max of the two things, is now going to be equal to the larger of the two, which is going to be y. And here you will have utility equals to x. Right, so this is how things are going to change now. 2x, y, x, 2y. So we have 4 regions now. Okay, region 1, region 2, region 3, and region 4. So we really have 4 regions now, not 3. So that is the difference. So now I can proceed to draw the curves. Okay, I can draw the 3 regions. Dashed lines. Okay, once you figured this out, after that the question is very easy. After you figured out the concept, what's the utility function in different regions, after that it's fairly easy. So region 1 is 2x. So you can take any utility value. is y, this is x. You can take any utility value, let's say 4. So 2x equals to 4 is x equals to 2. So x equals to 2 would look like this, vertical. Then y equals to 4. Then x equals to 4. And finally 2y equals to 4, so y equals to 2. So it would look like this function. Okay. This is what it would. The indifference curves would basically. All right, let's move to next one. Utility is max of x square y square. So can anybody tell me what this will look like?
Inverted L passing through x square is equal to y squared. Right?
Yeah, inverted and passing through x square equals to y square. Now, you see, max of x square comma y square is nothing but uh, a monotonic transformation of max of x comma y. Because if x square is greater than y square, it automatically implies that x is greater than y, because we are dealing with only non-negative numbers. So if you have two non-negative numbers x and y, then whenever x is greater than y, it automatically implies that x square is greater than y square. Okay, so for non-negative numbers, x greater than y is logically equivalent to x square greater than y square. So max of x square comma y square would be similar to max of x comma y, but obviously the reported value here would be x square, the reported value here would be x. Sorry, the reported value here would be x. So that is one slight difference between these two things, but the curves are going to be the same. It is just the nomenclature will change. I'll tell you how. Okay, why is this not cancelled? X. Okay, this is what question number 6. Question 6 is max of x square comma y square. All right, so x square. So x square will be reported. So utility will be equal to x square if x square is greater than y square, which is basically equivalent to x greater than y. So I will draw the same x equals to y line now. I'm going to proceed a little faster. To the right, you have x greater than y. To the left, you have y greater than x. So since you have x greater than y here, x square will be greater than y square. So utility will be equals to x square. And here utility will be equal to y square. Now let's take any utility level, let us say 4. So x square equals to 4. So x square equals to 4 is nothing but x equals to 2. Okay, x square equals to 4 is basically nothing but x equals to 2, because we are dealing with positive numbers only, non-negative numbers. So x equals to 2 would look like this. And to the left you have y square equals to 4, which is basically y equals to 2. So it would look like this. So you would really have functions like this. Now this would be utility equals to 4. This would be, let's say, utility equals to 9 and so on. So utility equals to 4 would be meeting at the point 2 comma 2. Utility equals to 9 will be meeting at point 3 comma 3. Now, had you instead taken the utility function as max of x comma y, then what would be the utility of this indifference curve passing through 2 comma 2? Had the utility been max of x comma y, let me ask this question to Disha. Disha, if the utility were max of x comma y, we have already determined that it would be inverted L shape. So what would be the utility value of the curve passing through the point 2 comma 2 if the utility were max of x comma y?
Sir, 16.
What? Hello, I couldn't hear you, Tisha. Just substitute 2 and 2 here and tell me what's going to be the utility value.
Hello, sir. 1, 6.
Why 16? What is x? What is x here? Can you keep your mic on for some time, please?
Hello.
Yeah. What is x at 2 comma 2? What is x?
Sir, it's 2.
And what is y?
2.
So what is max of 2 and 2?
2.
So why are you saying 16?
Sorry.
So the utility value here is going to be 2. The utility value here is going to be 3 if you go with utility equals to xy. So utility x square comma y square is nothing but utility xy. It's just that utility values are going to be the root of whatever it was earlier. Okay, so the curves will look the same. It's just that the utility values for the x square y square will be 4 and 9. Okay, so for x square y square is going to be 4 and 9. For max x comma y, it's going to be 2 and 3. So that's it. That's the only difference. Okay. All right. Seventh question. Min of x plus 3y, 2x plus 2y, and 3x plus y. So this is interesting. Does anybody know? Can anybody describe what it would look like if anybody has done it? Min of x plus 3y, comma 2x plus 2y, comma 3x plus y. Okay. So in this case, there are 3 functions now. I have to find a min. So it gets a little more trickier. So utility would be equal to x plus 3y if, so utility would be equal to x plus 3y if 2 conditions are satisfied. That is, x plus 3y should be less than 2x plus 2y, and x plus 3y should be less than 3x plus 1. Okay, so utility is min of 3 things now. Okay, so min of 3 things means it will choose the smallest possible thing. So it will choose x plus 3y as the min if x plus 3y is smaller than all the remaining things. Okay, so x plus 3y will be less than 2x plus 2y if y is less than, so you can cancel things out, right? So you can cancel this 2y here, and you can cancel this x and x here. So y less than x, and this would happen when again you can start canceling things. So this would happen when 2y is less than 2x. Now both these
So
things are
in
basically
the
same. Yeah,
first one, it's x plus 3y and 2x plus 2y. Then how are we canceling it?
I'm canceling
This
3y.
3y
The
and
3 is
2y.
cancelled. Y is remaining.
Acha,
That's
only
the
y.
way I work. Okay.
Okay.
So I have cancelled
Okay,
the
sir.
3. I kept 1 here. Okay. I'm not cancelling it totally. Uh, and I'm cancelling this 2 here with this entire x. So here x is remaining. Here this entire 2y is cancelling with the 2 here. So y less than x. Okay. And here I'll be left with I can cancel this x plus y on both sides. X plus y I can cancel on both sides. So here I'll be left with 2y. Here I'll be left with 2x. So 2y less than 2x. Okay. Now both these conditions, they are not different. They are the same condition. So the basic condition is when y is less than x. So whenever y is less than x, the reported value will be x plus 3. Okay. Now the reported value would be equal to 2x plus 2y if 2x plus 2y is less than x plus 3y, and 2x plus 2y is less than what is this? 2x plus 2y is less than x plus 3y, and 2x plus 2y is less than 3x plus 1. Okay. Now, when I resolve this thing, it just gives me x less than y. And when I resolve this thing, it gives me y less than x. Now, the intersection of these two things, x should be less than y and y less than x. Now, both these things cannot be simultaneously true. There would be no point in the Cartesian plane where both these things would be true. So this would never happen. So the idea is x plus 2y, if it is less than this, it cannot be less than this. If it is less than this, it cannot be less than this. It cannot be simultaneously less than both these things. All right. And now finally, when will the utility function report 3x plus 1? So here you can use common sense that to the right of 45-degree line, this is happening. This thing is never happening. So to the left of 45-degree line, this should be happening. So I should be getting this region as x less than y. But I would do it now because we are in the starting phases of learning these things. So I do it step by step. But in an exam or later on when you're doing such problems, you can obviously use these logical shortcuts. So 3x plus y will happen if 3x plus y is less than x plus 3y. And 3x plus y is less than 2x plus 2y. Okay, so this would happen if I resolve this, this becomes 2x less than 2y. And if I resolve this, this becomes x less than y. So the combined equation is x less than y. Both are the same things. So after this step, I'm ready to draw my indifference curves. So I really just have one line to worry about, that is x equals to y, because to the right of x equals to y something is happening, to the left something is happening. So I'll just draw one line, that is x equals to y. Okay. To the right of this line you have x greater than y. To the left you have x less than y. So here you would have utility equals to 3x plus y. And here you would have utility equals to x plus 3y. Right? So this is something we have already established. So I want to ask this question, next question to you, Akshi. If utility function is 3x plus y here, what is the slope of the indifference curve? Remember, slope is when you resolve an
Sir,
equation in y equals to mx. Yeah, you Akshi.
Sir, sir, how I calculate is like this: for every 1 unit in on x-axis, the y will be at 3. So it will be like how I can explain. It will be a straight line parallel to y-axis.
See, no.
No, that I mean that for every one, sir, it will be a line which will be more like, what do we say that?
See, things like slope are not open to interpretation, Akshi. I don't care how you solve it. Maybe you have taught yourself or somebody has taught you in a different way about what I'm teaching. But the question I'm asking is very objective. It is like, what is the slope of the indifference curve here?
Sir,
It
so
will be,
will be 3.
it won't be 3. You have to resolve it in this format. Take any utility number, take utility number 12, resolve it into this format and tell me the slope. What would be the m value? Okay, if you write this in y equals to mx plus c format, you actually, what would this equation become? If you take y on one side, just
Sir,
y on one side and everything else on the other side, what would this equation look like?
3x, 12 minus 3x.
Yeah, y equals to 12 minus
12
3x.
minus 3x.
So what is m now?
Oh, sorry. Okay, sir, minus 3.
Minus 3. Yeah, 3 and minus 3 are not same. It's high time you guys realize this. 3 and minus 3 are not same. Okay, so when I ask slope, I'm asking you. When I ask the magnitude, I'm okay with magnitude. But when I'm clearly asking with the slope, give me the slope, and I've given you the very basic idea of how to do it. So don't go on and confuse yourselves. Like just slope is -3. Okay, so what would be the slope here, Yuvakshi? Do not rush. Write it down. I hope you're sitting with a notebook.
Yes, sir.
Convert it into this format and give me the exact value. I'm waiting for you. No need to write.
So -1/3.
Very good. -1/. Perfect. Okay, so I hope everybody understands this. The slope is -1/3. So now what happens is, now the final thing is the indifference curve. So the slope would be -3 here and -1/3. So it would look like this. Okay, so the ICs would look like this. Okay, so next is okay. I'm leaving. I've spent too much time, but I'm leaving these 5 for you. I'll share the solutions with you guys, and let me know if you have any doubts. I'll share it today. Tomorrow we have a doubt session anyway. So in tomorrow's doubt session, you can ask me these doubts if you have any. So I'll share the solution, the max solution I'll share. Okay, so I hope you would be able to tackle them better now. The things that you would not have been able to do earlier, you should be able to do. Okay, let's move to the next topic. The next topic is marginal rate of substitutions, MRS. So the idea of MRS is that it is the rate at which I'm able to substitute one good for the other without changing my utility. Okay, so suppose I'm interested in having 2000 calories of food every day, right? So if you go to any nutritionist, they'll say what you do is don't eat sugar. If you feel hungry, eat a fruit or eat something else. So what they're saying is that don't eat too oily stuff. Eat something which is raw, like a carrot or a cucumber. So what they're basically saying is that uh, replace or substitute your high fat and high sugar things with low fat, low sugar. So it's a similar idea that if I want to reach some level of utility, I could have more of good X or I could have more of good Y. So I can substitute between the two things. Okay. So suppose you are at this point on your indifference curve. Now, if you were to give up this much amount of good X, but gain this much amount of good Y. Okay, so you lose this much amount of good X, but the amount of good Y increases by this much quantity. Okay, I should draw some other figure first. Suppose this is some indifference curve that you have, and you're starting at this point. So at this point, you lose this much amount of good X, but you gain this much amount of good Y. So start off from point A, you end at point B. Between A and B, your utility does not change, right? When you move from A to B, your utility does not change. It remains the same. So you have basically substituted delta X amount of good X with delta Y amount of good Y. So your marginal rate of substitution is, sorry, your rate of substitution is minus delta X, since you're losing good X, giving up X is considered as negative, upon delta Y. So this is rate of substitution. Okay. Now, marginal, the word marginal in general means for very small quantities, at the margin. At the margin, exactly. For very small quantities, the marginal rate of substitution, what happens is this delta, it becomes D. Okay, D is a very small change in amount of X. So for very small change in amount of X, what happens is that this dx and dy, these are very small changes, and dx upon dy, sorry, no, wait, it was dy by dx. I made a mistake. Delta y by delta x. Huh? I made a mistake, sorry. So it becomes, for margins, it becomes dy by dx. Now dy by dx is nothing but the slope of any curve, slope of the indifference. Okay, so you are starting at point A, and if these differences, deltas, are large values, then it will not be slope. Okay, then delta y by delta x will be the slope of this line segment connecting points A and B. But if the slope is, if the change is very small, then the delta dy by dx will basically be the slope of the indifference curve. That is the idea. Okay, dy by dx is the slope of any curve. So MRS is nothing but negative of the slope of the indifference curve. Okay, now what is the meaning of MRS? So at this point, exactly at point A, if the ratio of exchange of good y and good x is having the same value as the slope of this curve, then you are going to be indifferent. For example, let's say the slope at this point is 2, -2. Okay, I'm interested in the magnitude, so I might say 2, but the slope really is -2 because indifference curves are downward sloping. Okay, so what this means is that minus dy by dx should be equal to minus of -2, so that should be equal to 2, and this is equals to your MRS. So your MRS is equals to 2. All right. Now MRS is really change in amount of good y upon change in amount of good x. So suppose this is, always remember MRS as delta y by delta x minus of delta y. So let's say the change in quantity is very small. So suppose somebody changes delta y by 0.02 units and delta x is minus 0.01 units. So in that case, delta y by delta x ka negative will remain 2. So in that case, what happens is, if somebody gives you 0.02 units of extra y and takes away 0.01 units of good x, then your utility will not change. Okay, your utility will not change in this consideration. But if this rate is different, okay, then what happens is, suppose if somebody takes away 0.02 units of good x is okay, then the rate at which your goods have changed is 1. Okay, so delta y by delta x is actually now equal to 1, which in magnitude is lower than the MRS. Okay, so if the actual change ka magnitude is less than MRS ka magnitude, in that case, what happens is you become worse off. Why did you become worse off? Because your MRS was 2, which means that in order to be indifferent, if somebody gives you 0.2 units of y, you were willing to give away 0.01 units of x, but you had to part with 0.02 units of x. So what happened is that you were willing to do this trade, but the trade which you had to do were this and this. So you are at this point instead of this point. You get the same small amount of y, but the change in x is now larger than what you were willing to do in order to remain indifferent. Okay, so if the ratio of change is lower than the ratio of MRS, then you have become worse off. If the ratio of change is greater than that of MRS, so for example, instead of 0.2 and 0.1, what you get is 0.4 and 0.1. So now the ratio of change is 0.04 divided by 0.01. So that is equal to 4, which is greater than the MRS. So what's happening is that the change in X is still 0.1, but the change in Y is larger. So you actually reach a higher point, and you reach, incidentally, you happen to reach a higher indifference curve. Okay, so that's the idea. If the ratio of change is same as that of the ratio of MRS for small changes, then your utility does not change. But if the ratio of change is larger, then your utility will be changing by a larger amount. And if the ratio of change is slower, then your utility will be going down. Okay. Now, what is the role of MRS will become clear, but it is going to be the most important tool. But calculating MRS as dy by dx is a little trick, because in order to calculate MRS as dy by dx, you have to rely on using the explicit form of the equations. Okay, so explicit form is suppose y equals to x square plus y square is equals to 10. Okay, so this is explicit form. The implicit form, sorry, this is implicit form. Implicit. X and y are sort of intermingled with each other. The explicit form of the same equation would be y equals to under root 10 minus x squared. So this would be explicit form. So explicit form is always y on one side, everything else on the other side. So when you write an equation as x plus y equals to 10, this is the implicit form. When you write it as x equals to y equals to minus x plus 10, this becomes the explicit form. This becomes the explicit form. So, when we are calculating MRS as minus dy by dx, which is basically differentiation, I always need the explicit form. Now, I want to utilize the implicit form as well. So I'll give you an example which is very real world. The real worldly example is the Cobb-Douglas format. So under root xy, utility equals to under root xy. So suppose you want to plot the indifference curve for utility level of 10. Okay, so the utility level 10 is equals to under root xy. So this is the implicit form. The explicit form would be you square it up, so you get xy equals to 10, and then you take x on the other side, so y equals to 10 by x. So this becomes the explicit form. Now, if I want to use the formula that MRS equals to dy by dx, I need to have the formula which looks like this, because now I can differentiate this function 10 by x with respect to x and get my MRS as minus 10 by x squared. But I cannot do it here directly. So therefore, instead what I do is I use the implicit function theorem and I derive a new format for this. Now the formula here is derived from implicit function theorem, which we have not done yet. Okay, implicit function theorem is something that we will do later on. So I will come back to this example when we do implicit function theorem. For those of you who might have forgotten differentiation, I will do it, but it will take us some time to reach there. So in the meanwhile, I would like you to just remember this formula because we use it very often. So the formula is MRS equals to del u by del x upon del u by del y. Okay, del u by del x is partial differentiation of u with respect to x. Okay, so it's basically differentiation of utility function with respect to x, and this differentiation of utility function with respect to y. So how do I put it into practice? So I want to differentiate this utility function. So the utility function is really just under root xy. This is the utility value. The function is root xy. So utility equals to under root xy. I want to find the MRS, not MSR. So this is del u by del x upon del u by del y. Okay. Now, for those of you who have not done utilities, I would just recommend you to go through these videos on, sorry, not done differentiation. So you can go in the batch that we have here, go into videos section, maths, real analysis, and there's this derivatives. Okay, I have not uploaded anything here. So must be in the live classes section. So you go into the live classes, and if you scroll down, you should be able to see math lectures on differentiation. Real analysis, math lecture. Okay, one of these should be it. I'll just search for it and upload it in the video section for you guys. If you want to revise it, I'll upload it in a couple of days. So I have it somewhere on my laptop. I think I've not uploaded it yet. So I'll upload it for you guys and you can revise it. Other than that, if you go in the study material, in the math section, there is real analysis. You have these derivatives. So in derivatives, there's this differentiation.pdf. So I want you to do this problem set. Like, go over this if you haven't revised this or need some revision with it. Please do this once. Okay. I'll just give you a working formula right now for derivatives. So if your function, what is differentiation? Differentiation is, we are measuring the change in utility when x changes, keeping y constant. So this is change in utility when x changes, but y is constant. And this part is change in utility when y changes and x is constant. Okay. So in general, if you have a function f equals to a x to power b y to power c, where a, b, and c are constants. Okay, let's say a, b, and c are constants. So del f by del x will be equal to, when you're differentiating with respect to x, you keep these things as constants. So the constants remain as it is. So you write a y to power c, and differentiation of this thing would be b x to power b minus 1. So that is the formula. And del f by del y would be a x to power. Now, when you're differentiating with respect to y, del u by del y, x is constant, right? So since x is constant, you keep this thing as it is. So ax to power b remains as it is. Y to power c ka differentiation would be c times y to power c minus 1. Okay. So with that in mind, I want to differentiate this. So I can write this as u as x to power half, y to power half, right? Because root xy is what? Root x into root y, and root x is nothing but, for positive values, root x is nothing but x to power half, y is nothing but y to power half. Okay. So when I'm differentiating with respect to x, everything that is not related to x goes as constant. So y to power half remains constant into x to power half. So x to power half ka differentiation. So you take b as half. Okay, so like I told you, x to power b ka differentiation becomes b x to power b minus 1. So x to power half ka differentiation would become half x to power half minus 1. So that is half x to power minus half. Okay, so this would become y into half into x to power minus half. And similarly, del u by del y would become x half. Since it's symmetric, you can just write the symmetric result. And the final MRS is, when you divide these two things. So I'm going to divide these two things. So when you divide it, the half cancels out, and what you're left with is y to power half into x to power minus half upon x to power half into y to power minus half. Now this y to power minus half can go up, this x to power minus half can come down. So this becomes y to power half into y to power half upon x to power half into x to power half. So that is just y by x. Okay, differentiation is the key. Differentiation is going to be important. Only this much of differentiation is sufficient for now. So I would recommend that you go into this document which I just told you about for differentiation. Forget the initial few lectures, that is the theory of differentiation and everything. Just start with some problems. Okay, so just scroll down to the problems bit and yeah, d by dx of x. So d by dx is just differentiation. So they have some good examples like differentiation of x. So you can write this as x to power 1. So x can be written as x to power 1. So x to power 1 is x to power 1. So differentiation is 1 x to power 1 minus 1. Okay, so they give you a formula. They give you some examples. And then they give you some problems. Okay, and then they give you solution of those problems. So it's a very good exercise. So do it for a first few chapters, that would be sufficient. Okay, so under root x and so on. So just do some examples and we should be good with that. So if you need any revision, if you have not done it, then I would recommend to go through the videos once and then do it. So I'll share the videos with you, and then you can do it. All right. So that is how we find MRS. So let's do an example where we are trying to find the MRS of the utility function at different points. So the utility function is under root xy, and we set utility equals to 10. So the equation becomes, as I told you, y equals to 100 by x. Okay. So MRS by dy by dx formula, or dy by dx for this case. So you can write this as y equals to 100 by x is 100x to power minus 1. Okay. So in general, my thing is that 100 is a constant, so it remains as it is. So dy by dx is 100 is a constant, so it remains as it is into x to power minus 1. So this would become minus 1 x to power minus 1 minus 1. So that is minus 100 x to power minus 2. Now x to power minus 2 is 1 by x square, so this becomes minus 100 by x square. Okay, so MRS is negative of slope, so you put one more negative in front of it, so you get MRS as 100 upon x. Okay. So if I want to find the MRS at 3 points, let's say A, B, and C. So point A is 5, 20, point B is 20, 5. So suppose these are just 2 points. So I have found out that MRS is 100 upon x square. So here x is 5. So MRS at point A becomes 4, whereas MRS at point B becomes, point B is 20, 5. So 100 by 20 square will be equal to 100 by 400. So that is equal to 1 by 4, which is equal to 4. So that is how we can find MRS using this technique as 4 and 1 by 4. Now, if I want to find the MRS using the other technique, which I just discussed, so utility equals to under root xy, which can be written as x to half, y to half. So you can write the MRS as just y by x. Okay, so I've already done this part. I've done this part. Now, since MRS is y by x, you can use this formula to find MRS at point A as y value, which is 20, by x value, which is 5. So 20 by 5, which is equals to 4. And similarly, MRS at point B, which is 20 comma 5, would be equal to 5 by 20. So that is 1 by 4. So the MRS here is 4, MRS here is 1 by 4. So what is the meaning of this MRS change? So MRS is technically, MRS is negative of change in y upon change in x. So MRS is 4 here, which means that if you if delta x is 1 here, if delta x is 1, then delta y must be equal to minus 4. Okay, so if you give me 1 unit of x, I am willing to give you 4 units of y in exchange for 1 unit of x. Okay, so here the trading happens at the rate of 4 units of y for 1 unit of x. Whereas here MRS is 1 by 4. So for 1 unit of x, I am willing to give only 1 by 4 units of y. So the trading here happens at the rate of 1 by 4 units of y for 1 unit of x. So MRS can actually be defined as the amount of y that a person is willing to exchange for 1 unit of good x. And it is changing. It is changing. Notice that it is 4 here and it is 1 by 4. So MRS is higher here. These are 2 points on the same indifference curve. Why are they on the same indifference curve? Because point A is, remember my utility function is under root xy. So under root of 5 into 20 is 10 and point B is 20 comma 5. So under root of 20 into 5 is also 10. So these are 2 points with the same utility. So they lie on the same indifference curve. But even for points on the same indifference curve, that is points A and B, my utility level, my MRS is different. So at point A, for any change in good x, suppose I am this consumer with MRS of 4. If you come to me with 1 unit of x, I'll give you 4 units of y in exchange. Whereas some other person is at point B. If you go to this person with 1 unit of x, he will only give you 1 by 4 units of y in exchange. So why even the same person at different points will behave differently? Even if it's the same person at this point, he is willing to exchange 4 units of y for 1 unit of x. But at this point, he is willing to exchange 1 by 4 units of y for 1 unit of x. The reason is that there is a relative abundance of x here. If you see, if you just compare these 2 points, here he has more x. And here he has less x. All right, so x, when you have more of it, okay, when you have more of x, or you can compare y, okay, or you can compare y. Let's compare y, that will be easier. Here he has less of y, here he has more of. So when he has more of y, he's willing to part with y much more readily. So for 1 unit of x here, he is willing to exchange 4 units of y because he is relatively richer in y. Whereas here, for 1 unit of x, he is willing to exchange only 1 by 4 units of y because he is relatively poorer in y. He does not part with his y so easily. So at the point 20 comma 5, he has only 5 units of y and 20 units of x. So he has a lot of x but very less y. So he does not give y easily. So y is relatively costlier for this guy at point B. But at point A, he has 20 units of y and just 5 units of x. So he's like, I have a relative abundance of y, so I can give away y much more easily. He's never going to give anything for free. That would definitely make him worse off. Here we are seeing how do points A and B compare with respect to the rate of exchange of this. Okay, so we are just going to compare these 2 points with rate of exchange. Okay. All right. Now we have this constant elasticity of substitution utility function. For which we have to find the MRS. Okay, so let us do this problem. This will also help us do some revision on differentiation. So utility equals to a x to power r plus b y to power r whole to power 1 by r. So first thing I'll do is I'll do a monotonic transformation. I'll take this function v as u to power r, which will be a x to power r plus b y to power r whole to power 1 by r ka power r. Okay, I'm taking a power r on u. U is this entire thing. So entire thing to the power r. So what happens is this r and 1 by r cancel out. So what I am left with is a x to power r plus b y to power r. Okay. Now next thing is differentiation. So del v by del x MRS is equals to del v by del x upon del v by del y. So one important property is MRS does not change under monotonic transformation. So if you do monotonic transformation, MRS will not change, because what happens is that changes in u in the numerator and denominator, they exactly cancel out. So del v by del x upon del v by del y will actually be equal to del u by del x upon del u by del y. Okay. So this thing will not affect the MRS. So with that in mind, I can just differentiate v function because it is easier to work. All right. So this v function has really 2 parts to it. This is part 1 and this is part 2. Now first thing is I differentiate this entire thing with respect to x. Now the right part of this function, which comes after the positive sign, it does not have any presence of x. So when I differentiate it with respect to x, this thing becomes 0. So the property is, if you have a function f which is, let's say, u1 plus u2, then del f by del x is basically del u1 by del x plus del u2 by del x. So you can write this as u1, this as u2. So del u by del x will be equal to del u1 by del x plus del u2 by del x upon del u1 by del y plus del u2 by del y. Now u2 has no presence of x in it. So when you differentiate, so it's like a constant. It does not depend on x. Remember the definition of del f by del x. The definition is change in f when as x changes. So del u2 by del x is change in this function as x changes. Now this function has no presence of x, so this does not change when x changes. So this is 0. Similarly, del u1 by del y. So change in this function has no presence of y in it. So this function does not change when y changes. So this thing becomes 0. Sorry, this thing becomes 0. Okay. Now differentiation del u1 by del x. So del u1, so u1 is a x to power r. So del u1 by del x is from the property a times x to power r ka differentiation is r x to power r minus 4. So this is del u1 by del x. And so this becomes the numerator. Similarly, del u2 by del y is the only thing which will remain here. So when you differentiate this thing with respect to y, it becomes b r y to power r minus 1. So finally, your del MRS is the ratio of these two things. So that would be equal to AR x to power r minus 1 upon B r y to power r minus 1. R cancels out. So this becomes A x to power r minus 1 upon B y to power r minus 1. So A by B into x by y to power r minus 1. So the important thing here to note from an economic standpoint is that the MRS can be found out if you have x by y ratio. So suppose I give you the information that the consumer is consuming twice of x as of y. जितना भी y वो consume कर रहा है उससे x double है. That is the information I'm giving you. So what this means is that x by y is equals to 2. So for this consumer, what happens is MRS will become A by B times 2 to power r minus 1. Okay, A by B into 2 to power r minus 1. A, B, and R are all constants. Okay, so these are constants which cannot vary. X and Y are the only variables here. So X and Y, I do not need information on X and Y. Just the ratio of X and Y is sufficient to find MRS. So such preferences are called homothetic preferences. So homothetic preferences are the ones in which you can find the MRS if you have just the ratio of X and Y, and you don't actually need the absolute values of X and Y to find the MRS. So such preferences are called homothetic preferences. Why are they called homothetic preferences? I'll come, and why are they important? I'll come to it in a bit. All right. So you have to find the MRS of these few functions using whatever I've told you. You can either use the slope formula or you can use the MRS formula, whatever you want to use. Let's look at this problem now. So this problem says that graphing part you can leave for now. We'll do it after. You should be able to do it after we have done the graph plotting curve sketching example. If you already have that knowledge, then maybe you can try it right away. But graphing is not that important. The important thing is to understand, to get the function MRS and to see if it is convex. Now, how do we find if MRS is convex or if indifference curves are convex or not? So the way to check it is that MRS declines as x increases. So for this function, I have already found out MRS to be equal to y by x. So as x increases, y by x will reduce. This implies that the preference or the ICs are convex. Let's look the third example. So MRS is del u by del x upon del u by del y. When I differentiate with respect to x, this part is constant, so this part becomes 0 because it is added. So if a constant is multiplied, it remains intact. If a constant is added, it dies. So this is constant with respect to x. Right, so this thing will die when you're differentiating with respect to x. It will cancel out basically. And under root x ka differentiation is x to power half. Ka differentiation is going to be half x to power half minus 1. So that is half x to power minus half. So that is 1 by 2 root x. So del u by del x becomes 1 by 2 root x. 1 by 2 root x. Upon, when you're differentiating with respect to y, x part becomes 0 and then differentiation of y. So y to power 1 ka differentiation is 1 time y to power 1 minus 1, which is 1 into y to power 0. Anything to the power 0 is 1, so this just becomes 1. Now, as you can see, this thing also reduces with x. As x increases, denominator increases, so the overall fraction reduces. So this thing reduces with x. All right, so this thing also reduces with x. Similarly, you can check for the other things and you can find out if what the MRS is and if it is increasing or decreasing. Feel free to use any monotonic transformations. Okay. All right.
So,
Now, yeah, Kritika.
so we can also differentiate MRS with x, and if it is less than x, then if it is less than 0, then it is convex. Like
Yeah, if you
if
want to do that,
in
yeah,
for the
definitely.
functions where we can't find out that
Yeah, definitely, you are correct that you can go ahead with one more step and you can check it. But I don't want that complexity right now. If at all required, if the question demands it, then yes, like in these two remaining parts, if you cannot tell it directly, you go that step. Here, I don't need all that. I know here that as x increases, the function must reduce. So I don't need that much complexity in my analysis. Right?
it's for the questions where we can't determine actually
Yeah.
that with the increase in x, if MRS is
Yeah.
increasing or decreasing.
Yeah. So in that case, you have to differentiate MRS and C. Definitely. Totally correct. Okay. So in these problems, what you have to do is you have to show that MRS is diminishing, like I told you. The other thing is marginal utility. What is happening to marginal? So MRS is basically del u by del x upon del u by del y. Now this del u by del x is nothing but marginal utility of good. Now what is marginal utility of good x? So marginal utility of good x is basically change in utility when consumption of good x increases by 1 unit. So if you increase the consumption of good x by 1 unit, your utility, the amount of change in utility is marginal utility of good x. Similarly, the lower thing is marginal utility of good y. All right. So if I take this utility function, then what is the marginal utility? So if I take this utility function, then utility equals to xy. So marginal utility of good x is del u by del x, which is x into x to power 1 y to power 1, right? So this is d by dx of this value. Y to power 1 is a constant multiplied, so it remains as it is. And x to power 1 ka differentiation I've already seen is 1. So this is just y. So marginal utility of good x is y, which is basically constant with respect to x. Why do I call it constant with respect to x? The idea is, suppose that good x is ice creams. Suppose good x is ice creams and good y is chocolates. Okay. So I'm saying that marginal utility of good x is y, which is, let's say, so suppose you are at the point 2, 2. So you are consuming 2 ice creams and 2 chocolates. So your marginal utility of ice cream is 2 because your y is 2. Now suppose I give you one more ice cream. Instead of 2, 2, you go to 3, 2. So when you go from 2, 2 to 3, 2, your utility change because of an additional unit of ice cream, it will, your utility will go up by 2 units. So it increases by 1 unit. Sorry, by 2 units. So the marginal utility of the third ice cream that you have. So at 2 comma 2, your utility is 4. At 3 comma 2, your utility is 6. So as you increase the consumption of ice cream by 1 unit, your utility increases by 2 units, which is basically your marginal utility. So when you increase the consumption of ice cream by 1 unit, your utility will go up by 2 units, which is equal to your marginal. Now this y is constant with respect to x. It does not change. As x changes, it will not change. But for some other function, this thing might change. For example, under root xy. Let's take utility function as under root xy. As already established, marginal utility of x for this thing is del u by del x, which I have seen is under root y upon 2 root x. Now, as you can see, this function under root y by 2 root x, this function, if you increase x, this overall thing reduces. So as you keep on increasing the consumption of ice cream, the utility for each ice cream is going to keep on reducing. So let's take y is root 2 comma 2. So you start from 2 comma 2. Okay. So utility is under root of 2 into 2, so that is 2. Then you go to 3 comma 2. So utility is under root of 6. Now, so the change in utility is root 6 to root 2, root 6 to 2. Okay. You increase it to 4 comma 2. So now the utility is under root 8. So this difference is root 6 minus 2, and this difference is root 8 minus root 6. This thing is smaller than this thing. So every next ice cream gives you lower and lower utility. That is what we have. So this is a case of diminishing marginal. Whereas this is a case of constant marginal. So in the remaining questions, you have to find if marginal utility is constant, increasing, or decreasing. Then there are these couple of problems which you have to look at. All right. So I'll discuss this in the next class. And finally, let's come to utility maximization. So now that I have my ideas of MRS ready, I want to go into utility maximization. So utility maximization is basically the main problem of consumer theory. The main problem of consumer theory is, given an income and some prices, how does the consumer decide what to consume? Okay, so I give you some income. Let's say you have 100 rupees, and you know the prices which are prevalent in the market. 5-star costs 10 rupees, an ice cream costs 20 rupees, and so on. So given your income and your prices of the world, you want to now go out and purchase stuff. So what is the mechanism which will decide how much you purchase and how much of what you purchase? So in order to solve this, we begin with 3 assumptions. The assumptions are basically local non-satiation. What is local non-satiation? So local non-satiation just says that given any point like sure. second. Ah, no. So local non-satiation says that given any point A, if you construct a neighborhood around a small circle of points around A, in this small circle of points, you will always find another point A prime such that A prime is strictly preferred to A. So local non-satiation basically says that for any point in the consumption bundle, in the vicinity of this point, there would always be another point which is strictly more preferred to this point. Okay, so that is local non-satiation. When is local non-satiation not true? So local non-satiation is not true in situations where the consumer has a bliss point. A bliss point is a point with maximal utility and no other point is better than this. For example, if you go out to eat with your friends and your friend says that he'll pay the bill. Okay, even if the friend says that he's going to pay the bill, you do not go on and keep eating like there's no tomorrow. You eat maybe more than what you would have eaten if you were paying the bill, but after some point you would stop. That is your bliss point. Any more food, if I put any more food into your mouth, it will reduce the bill. Okay, so when situations like bliss point happen, we say that the consumer is satiated. Satiated means in Hindi the word is tript. Okay, tript ho gaya. He is satisfied. He cannot be any more satisfied. So we are saying that the assumption is no local satiation, which means that the utility has no local minimums. So to understand this point, imagine the, yeah, Kritika, do you have a doubt?
No, sir. Sorry, it was my mistake.
So to understand the concept of local non-satiation, think of the utility, think of different points on the surface of the Earth. And the higher altitude that you reach, the higher would be your utility. So if you're at the peak of Mount Everest, you have the maximal possible utility. There could be no other point which will give you a higher utility than Mount Everest. Okay, your utility is just the altitude at which you live. Okay, suppose that is the simple concept of utility that we have. So the higher you are, the happier you are. So if you reach the peak of Mount Everest, you're happy. Okay. Local non-satiation is somewhat less less stringent than that. In the sense that local non-satiation or no local satiation says that you should not be at any local peak also. Suppose instead of Mount Everest, you go to Anaimudi. Anaimudi is the highest peak of Karnataka. No, sorry, Kerala. So you go to Anaimudi and you are on the peak of Anaimudi. Now, if somebody says, if you want to move 1 or 2 kilometers away from Anaimudi to any other point, you would say no, because any other point within a 1 kilometer distance from Anaimudi is at a lower altitude than Anaimudi. So local non-satiation says that if at any point you would always be willing to move to at least some other point in a local circle. So you don't have to reach Mount Everest. He's not saying that you are not at Mount Everest. He is saying that you are not even at Anaimudi. Wherever you are, there is some direction in which if you move, your utility will increase. Maybe this direction, maybe this direction, maybe this direction, I don't know. But wherever you are, there is at least one direction in which if you move, your utility strictly increases. Okay. So local non-satiation in optimization terms basically implies that no local maximum. No local maximize present. So utility function always keeps on increasing, at least in some direction. So if both commodities are goods, it keeps on increasing in the infinite direction. So you keep giving the consumer more and more, his utility will keep on increasing. So a situation like you going to a restaurant and saying, I cannot eat no more, is never going to happen in local non-satiation. So more is always preferred. You keep on preferring more. Okay. So keep preferring more, more and more. So that's the idea of local non-satiation. The next is no utility from wealth. This just says that saving wealth is not going to give you any pleasure. Now, generally, this is not true. Generally, we know from fact that our parents don't spend everything. Even when we start earning, we will not be spending everything. We'll keep some savings for a rainy day. Here we are saying that the consumer does not get any utility from saving his wealth. He only gets utility from consumption. Okay. And the third is market economy. Market economy just says that your consumption levels are not going to change the prices. Generally, we say that demand increases prices. So it's not that if I buy 10 kgs of rice in the market prices for rice will go up. Right? That won't happen. So that's the assumption here, market economy. So prices are constant. You get no, your consumer is going to spend all income and his utility function has no local optimums. Okay. So he keeps preferring more and more, and his so he'll keep preferring more and more. So that's the idea. So where does his consumption stop? That becomes the question. If more is always preferred, then you would keep consuming more and more without any stop. So the stop happens. The stop comes from the budget constraint. So ideally, because of local non-satiation and no utility from wealth and everything, if you had no budget, you will keep on consuming. But the problem is that we have a limited budget. So the limited budget implies that we cannot consume till infinite. So even though consuming more and more keeps us giving higher and higher utility, we do not do that because our budget is limited. So what is the budget constraint? So suppose we have an income I and prices of good X and Y are Px and Py. So the budget set, so we are going to define the budget set. So budget set is basically the set of all goods, all bundles X, Y, which are affordable. Set of all goods X, Y, which are affordable. Okay, so that's my budget set. So suppose if my budget is 10 rupees, sorry, 100 rupees. Let's say my income is 100 rupees. Okay. Good X costs 2 rupees. Good Y costs 5 rupees. Okay. So suppose I consume any bundle X, Y, where X is amount of good X, Y is amount of good Y. So the expenditure is going to be if I consume X units of good X, the expenditure on good X is going to be 2X. If I consume Y units of good Y, the expenditure on good Y is going to be 5Y. So suppose X is, let's say, melody, and Y is, let's say, 5 stars. So 2 times melody plus 5 times 5 star. So that would basically make it the total expenditure that I do. Now this total expenditure has to be less than or equal to. That is the idea. 2X plus 5Y should be less than or equal. Okay. So that is my budget set. This equation defines my budget set. Now, what does that set look like in the Cartesian plane? So for that, I first need to determine my budget line. The budget line is the set of all bundles which are just affordable. So this is the set of all bundles which are just affordable. The word just is important. The word just means a bundle which if I consume, my entire income is exhausted. So such bundles are going to be of the format 2x plus 5y equals to. So this is my budget. So these are all values of x and y at which my entire income is exhausted. So I can buy 50 melodies, or I can buy 25 stars, or I can buy 25 melodies and 10 5 stars, or some other combination. So this is going to be the line. Okay, 2x plus 5y equals to 100. Now, how do I plot this line? So plotting this line would look like this. This is x and this is y. Okay, so my line is 2x plus 5y equals to 100. So when you want to plot a budget line, the best way is to attack the axes. Okay, so what is y max? Y max is the maximum y that you can consume. So take x equals to 0. What is the maximum number of 5 stars that you can consume? So y max is equals to 100 divided by 5. You just make this thing 0. So the equation becomes 5y equals to 100. So that is 20. So let's say this is the point 2. And next thing would be what is x max. So x max is 100 by 2. You make y is 0. So you get 100 by 2. Right. So 2x equals to 100. So x is 100 by 2. So that is equals to 50. So that becomes this point. And then finally, you just join these 2 points. This becomes your budget line. And everything below the budget line, this entire triangle, is your budget sheet. All right. So now I want to find, so these are the bundles which are affordable, which I can purchase if I go in the market. And I want to find the bundle which gives me the highest utility. The equation of budget line is pxx plus pyy is equals to I. This is the generic equation for any level of px, py, and I. Okay. So for this budget set, I want to find the maximum utility bundle. So let's say my indifference curves, they look like this. Suppose these are my indifference curves. So now the point which is affordable and at the highest utility will be this point which is tangent. Okay, so this is, let's say, utility U1, this is, let's say, utility U2, this is, let's say, utility U3, such that U3 is greater than U2 is greater than U3. So obviously U3 is higher, but it is unaffordable. All utility functions, all indifference curves with utility greater than U2, they do not have any intersection with budget set. So no point on this budget line, on this indifference curve U3 is affordable. So even though I like U3 more than U2, I cannot purchase it. I'm not rich enough. Now U1 is affordable, but then it is at a lower level than U2. If I can purchase a bundle which gives me utility U2, why would I want to stick with U1? That is the question. So I won't stick with U1. So the highest utility I can reach is indifference curve like U2, which is the point, which happens at the point of tangents. So this is the ideal. So let me call this bundle as X star comma Y star. So how do I find this bundle? So in order to find this bundle, I have to find X star and Y star. Okay. So in order to solve this problem, I want to find the values of X star and Y star. So let us just quickly write down what do we know. Things we know. So things we know is income is I. We know Px comma Py is the price vector. And we know that utility function is u equals to u of x comma y. So these are the things we know. And with the help of these things, I want to find this x star, y star. So these are things we know. Things to find x star comma y star. This is what we have to find. X star comma y star. Now, how do I find x star comma y star? So in order to find x star comma y star, I need two equations. So I need two properties about x star y star. Property one is that x star y star lies on the budget line. Okay, it has to be tangency condition on the budget line, which implies that px times x star plus py times y star must be equal to I. X star y star lies on the budget line means x star y star satisfies the equation for the budget line. The equation for budget line is pxx plus pyy equals to I. So all points x comma y which satisfy this equation lie on the budget. So since x star y star lies on this budget line, it should satisfy this equation. And let me remove this thing. What is of appearance? Let me call it u star. And the second thing I'll know is that the IC and budget line are tangent at x star comma y star, which gives me the condition that the slope of IC must be equal to slope of budget. Okay. Now slope of IC is dy by dx. Slope of budget line. So budget line is pxx plus pyy equals to I. If I resolve this in y equals to mx plus c situation, resolve this in y equals to mx plus c equation, then what would be the slope? I am putting this question up for Ananya. Ananya, can you resolve this equation and tell me what would be the slope if the format is y equals to mx plus c? In terms of px, py, and I.
Sir, it will be minus px upon py.
Very good, very good. So I can write this as py into y is equals to minus px plus I, and then I can divide the whole thing with py. So minus px by py plus I by py. So I by py is not important. Slope is minus px by py. So the slope of budget line is minus px by py. So this is going to be true for all budget lines. As long as prices are constant, slope will always be minus px by py. Now regarding slope of indifference curve, we had already established that MRS is equals to minus dy by dx. Right. So slope, which is dy by dx, slope of the indifference curve, this will be equal to minus of MRS. So finally, we get minus MRS is equals to minus px by py. Okay. Now, Finally, we can write this condition as MRS equals to Px by Py. MRS equals to price ratio. That is the last condition that we derive from here. Marginal rate of substitution is equals to Px. So at this point, the equations that I have is MRS equals to Px upon Py, and another condition is that Px x plus Py y is equals to 0. So if I solve these two equations, I can get my solution. So let us do a quick example and then we can call it a day. Let utility equals to xy, Px equals to 1, Py equals to 2, income equals to 8. Find the optimum bundle x star y star. So I know that for this utility function, MRS, I've already calculated is y by x. So y by x should be equal to Px by Py. So 1 by. Okay. Remember that MRS should be equal to Px by Py. MRS is del u by del x upon del u by del y. A lot of times I see people making the mistake that since I'm writing y by x, it should be Py by Px. It does not matter what is here. What matters is what you are differentiating in the numerator. If you're differentiating with x in the numerator, price of x should be in the numerator. Okay. So whatever you are differentiating with in the numerator for MRS should be the same, because x and y might not be always same. Sometimes the examiner will give you goods, butter and bread and butter. So in that case, it's unclear what is x, what is y. So don't try to remember things like x ko upar rehna, y ko niche rehna. That would be difficult to execute an exam if the examiner varies the question or varies the variables. All right. So for MRS, whatever is the differentiation variable in the numerator is the price variable in the numerator. So that is what I want. So this implies that x should be equal to 2y. Okay. And finally, pxx plus pyy equals to x, 8. So pxx plus pyy, py is 2. This should be equal to 8. Now 2y is equals to x. So this implies x plus x is equals to 8. This implies that x must be equal to 4. So since x is equals to 4, y is equal to x by 2. So y should be equal to x by 2. So that is how we can do these problems. So with that, I'm going to leave you with some problem sets now. So you can go and study material, micro, consumer theory, problem sets. So chapter 2 budget constraint should be done. All right, so you can do this chapter, budget constraint. You can do preferences, utility. Yeah, utility also you can do. Yeah, you can do utility. So first 3 chapters, you can start with them. And do as many as you can. I'm sure you won't be able to do all of them in 1 week. So I'm giving you 2 weeks of time. After 2 weeks, we can discuss them. Okay. So, but you see, you have a lot of homework now, because set theory also I've told you you can do past years, and you have 1 problem set in set theory, and you have these 3 problem sets. So try to find time and do as many problems as you can, because things are going to get really challenging in the coming weeks because I'm going to keep increasing the magnitude of homework. So don't keep a lot of things for later. So do as much as you can right now. Okay. And what is the situation of your exams? When are you guys done with your exams or are they pending? Your graduation second year exams.
So DU will not be having exams. No,
Okay, so exams are
ours
cancelled.
are cancelled.
What about people from non-DU background? Are you guys done with your exams? Is everybody from DU here?
So from July.
From July, you have your exams. Okay, so your July exams are pending. All right, so obviously, when you have your exams, things will go a little slow. So make sure that whenever you have your exams, you let me know. I will probably go a little slower then. So the idea is I cover up more territory when you guys are free. I cover less territory when you have your exams. So let me know whenever you guys get busy with exams or other stuff. Okay. Since you don't have much to do right now, spend more time with it. All right then. Tomorrow we will have a doubt session. How about same time, 4 o'clock? It would hardly take an hour. So does 4 o'clock work for everyone?
So tomorrow will be just for the test.
Yeah, test and some problems of inequality if you have any doubts there, and some
Okay, so
problems from this one if you have doubts. If you have any doubts, so it should not take a lot of time. Uh, so even this min-max problems, I'll share the solutions with you, and then if you have any doubts, you can ask. I think the solutions. No, they're not. But I'll share the solutions so that you can compare your answers. Okay, so 4 o'clock we'll take a doubt session. If you have doubts, you attend it. If you don't, great. Saves me time as well. Okay. All right. Ending this class now. So I'll see you guys tomorrow for the doubts.
thank you, sir.
Sure. Welcome.
Thank you, sir.